Hello, Ben. How are you doing?
Hello, John. I'm doing good. Welcome back. It's been a while. The world's a bit different. People listening to this in the future might not realize it, but there is a global pandemic ongoing, and I am recording this from my home. If you hear a jingling, tinkling bell in the background, that is my cat leaping up onto the desk. So, how are you doing, John? How are you faring in these uncertain times?
Yeah, you know what? It's actually not too bad. It's actually not too bad. It's a different life to be living, but it means that I get to spend more time on various cool side projects. So maybe that's a good thing. Although I guess arguably I should be working and finishing my thesis, but
At one point, Rust itself was a side project, so who knows what things might, rise from the ashes.
That's very true. It's very true.
Sense. And fortunately, Rust development has always been highly distributed and remote heavy, and so it continues apace.
It's true. And one other upside of it being a while since last time we recorded is that we now get to record for not just one, but two Rust releases. Yeah, 142 and 143.
Let's jump into it. Maybe I'm not sure how long it will take. Maybe we'll have a little interlude in between to give our readers time to stretch their legs, but there's plenty of meat to chew on in this episode, so let's jump right in. 1.42.
So 142 was a pretty cool release, actually. I thought there were a bunch of changes in there that I've wanted for a while and that I think will really have an impact for people. And one of the first ones of these is that you finally get useful line numbers in option and result panic messages.
This is kind of, it's somewhat of a revelation to, it's one of those long-standing issues that people were like, it's kind of, you accept it as a way things are. Like, oh, obviously, if you panic, you're never going to get, a good line, not good line number in the error message. It's always going to point to the standard library, and I think people who have been using Rust for a long time might be kind of, habituated to even ignore the output of the panic message, but you have to unlearn that because now they're actually useful, it's amazing. It's a revelation.
Yeah, I know, right? Or I always have Rust backtrace set to 1 in my environment, and so I always get the full backtrace, and I've sort of trained myself to look about halfway down the backtrace before seeing anything useful.
Yeah.
And now that it actually provides something useful near the top, I'm very excited for this change.
Yeah, do you want to talk more about how the compiler achieves this and whether or not users can use this in their own code?
Yeah, so this actually required some kind of subtle changes internally in Rust, because what is needed here is to sort of unwrap needs to know where it was called from. And so the way this has been implemented internally is this new annotation called track caller. You can't actually use this annotation yourself on stable Rust, although you can on nightly behind a feature flag. And the basic idea here is that every unwrap turns sort of into a closure. So behind the scenes, Rust makes sure that every call to unwrap basically remembers where that call happened. And this has some implications for compilation as well and for optimization. And I recommend you take a look at the tracking issue and the underlying RFC if you're interested. I think one thing that's worth pointing out here is track caller is what's currently used to enable this, but track caller itself has not been stabilized because we're still trying to figure out some of the details there. But at least now we know that unwrap will give you the useful information, regardless of whether the underlying mechanism changes before it's stabilized.
Yeah, so currently the standard library uses this mechanism internally, and at some point in the future, hopefully users can use it as well in case they want to make their own kind of abstractions of this same kind.
Yeah. There was another cool change in 142, which is this notion of subslice patterns, and I hear that you maybe had a hand in this, Ben.
I don't know about hand. I know so. Just like the previous point, this one has been in the works for a long time, and the reason that this one took a while, as opposed to the previous one, which took a long time because of thinking about optimization concerns, code size concerns, this one was just syntax, which is the kind of the bane of every programming language designer's existence, where you at some point you need to kind of just pick something. Let's back up though. So a subslice pattern, if you're used to working with patterns in Rust or slices, you know that you can match on a slice of things and then put kind of like, if you have a slice of numbers like 1, 2, 3, you can have like match on that and say, hey, like, if this slice is, the empty slice, just like an open bracket, close bracket, do this. If it contains one element, you can like, bind the first element to this and then do two. If it contains two elements, you can do this, and you can give it a default pattern for, I don't know how many are in the slice, but you have to, because slices don't have any kind of compile time information about their size. In this case now, you can do something different. So if you're, I think JavaScript has had this for a while now, where you can kind of like there's this dot operator, the rest operator they call it, or I guess it's dot in JavaScript. But you can say, hey, like now in a pattern in Rust, you can say, hey, I want to match on this slice, and again, it's Rust, so slices don't have any length information, so we don't know how many are in here. But I want to just take out the first two items here, say, and then ignore the rest. And you can use the dot operator, which is generally used in Rust for ignoring a lot of things in patterns. And so,
yeah, I was gonna say, like, so
go on.
Some might argue that this is like extending the syntax, right? Like you're adding more complex syntax to Rust. Do you feel like that's true about this feature?
No, actually, I think this is a case of I judge language features based on whether or not they make the documentation larger or smaller. And in this case, I think this is a change that makes documentation smaller, because generally, if you have a feature and then you have to say, but you can't use this over here, and then you remove the need for that clause in the documents, you have made your language smaller. And so, like, I'm not sure if you've ever seen like a struct where you want to like, use like, I want to say like, hey, I have this struct or I have this thing, and I put, let me back up. So in Rust, if you want to, in a pattern, ignore exactly one thing, like one field in a struct or like one item in an array, you use the underscore. And they also have the dot pattern, which says, ignore all the fields in this or all the items in this array. And so it's kind of like just lets you, avoid writing a bunch of underscores, underscore, comma, etc. And so it's kind of like dot is ignore everything inside of this. And so now in these slice patterns, you can have like a few different things. You can say, hey, I want to like, the example given in the blog post for 1.42 is you have like, a hello world, like, a slice that says hello, comma, world, comma, and then you might have like, some other things in the end. And then you can like, I want to match on the slice that says hello, comma, world, comma, dot. And then if the slice has anything else after hello world, it'll still match that arm of the pattern. And obviously there are some restrictions here where you can't have more than one dot in a single pattern, because you have to understand like where should I look for, what parts should I ignore, what parts should I think are concrete. And so you can have the dot at the end, in the middle, the beginning, anywhere, but only one of them.
So what is the subslice part of this feature?
Basically, in other languages, so in like a functional language, you might be used to a pattern where you have you want to have a list of things and you want to get like just the head or just the tail of some kind of list, and then like recursively go over it and say, hey, like let's stop. The base case for my recursive list is when this is empty, and in the meantime, I want to like just grab the head, do a thing, pass the tail to the next recursive invocation of this function, and so on. And the dot pattern I was describing just now lets you ignore parts of a list, but not actually name them. And so kind of like throw them away, like you would expect from seeing an underscore in a pattern or in a let. And so if you want to name a pattern in Rust, this was kind of the crux of the syntax issue, which held up this RFC for a long time, which is what kind of syntax like we want to actually have for this if somebody actually wants to name the rest of the stuff that's being matched over. And so there are various proposals, and then this is where I came in, where just kind of being like, hey, actually, we already have syntax for this in the language. And so I think maybe in the previous podcast, we mentioned how in patterns, there are these things called at patterns. And so it's just the at symbol on your keyboard, and they let you name a pattern that is also being matched in some other way. And so last year, I think 1.41 perhaps, we're gradually making at patterns more powerful. There's kind of an artifact of Rust 1.0 where, because of some last minute unsoundness, we had to kind of limit at patterns in ways that we knew were a bit too restrictive, but there just wasn't time to actually go through and make it work properly. And thanks to some heroic efforts over the past year or so, people have finally managed to actually make at patterns sound again and operate the way they should operate. And so an at pattern kind of lets you say, hey, like I want to match on this pattern, but also bind the entire thing, and not just the insides, but the entire thing to some name.
Or specifically, like bind it to this name if it matches.
Mm-hmm. So, for example, if I have like an array of like just a 1, 2, 3 of numbers, and I want to match on this, I can have as a pattern, as like an arm of a match, I can say like, hey, like, I could say, bracket 1, comma 2, comma 3, match on this, or I could say, bracket 1 underscore 3, match on that. And I can also say like, bracket A underscore C, in that way. And in this case, it is totally symmetrically equivalent. If you said, bracket A, comma B, comma C, I could also say bracket A, comma B at underscore, comma C, which just says, hey, I want to match this one element, throw it away, but also bind it. It's semantically useless, but it's one of those things where it's like, yeah, you could do it. You definitely shouldn't, but you could. And we just leverage this fact. This is kind of syntax that already like exists and should work. And so the syntax for this subslice pattern, finally getting to it, is just like bracket A, comma B at dot dot comma C, where the B at dot dot just says, hey, we're using at patterns to match the rest of this thing.
Yeah, I feel like it's really neat, right? In some sense, it ends up being a very unsurprising syntax, I think.
Yeah, it's just we're composing elements of the syntax that already exist in other places. Again, it is, in my mind, it is a change that makes the language smaller because, like, it's instead of having to say, hey, you can't use this here, it's kind of just like, yeah, everything works as you expect.
Yeah.
So, and then the question is like, well, like the kind of like my proposal for this back in the RFC a long time ago was kind of, hey, like this doesn't mean that we can't sometime in the future have syntax dedicated for like subslicing in a way. And I think there's even an argument that we should. There are languages that, so generally in Rust, like a pattern is the opposite of some kind of like construction. So you're like destructing and constructing are two sides of the same coin. And so, for example, like in a pattern, if you use an ampersand to like match a reference, that means like the opposite of using an ampersand to like actually make a reference. So it says, hey, I want to like, dereference this thing because I'm matching whatever like is being referenced, and then like give me whatever was being referenced by this ampersand. And so if you have like syntax and patterns, you want to kind of have this two-way thing. And the question is, well, is it useful to be able to like have a slice and then like kind of like explode it outward? And yeah, actually it is sometimes. And so languages like Python have this kind of like unpacking in a way. I think that's the asterisk operator in Python does this, where if I have like, a list in Python, so bracket, 1, 2, 3, or let's say like I want to let's say I have a list where it's like bracket 2, 2, 3, 4, and then I have like I want to say make a new list, and so I might say A equals bracket 1 asterisk B, when B is my previous list, comma 5, and then A is now 1, 2, 3, 4, 5. And so I can unpack arrays into other arrays, which is just the opposite of what's happening here. So whereas in this case we are kind of saying, hey, like match this internal subarray, we could then imagine in other contexts we want to explode an array and unpack an array. And so right now there's no syntax for that in Rust. If we did have it, we'd probably want to make it general enough that it would work for both pattern contexts and normal contexts.
Right. And ideally, I guess you would want it to mirror the syntax that's now been introduced for matching them.
Yeah. And so, but again, this is not new syntax. All the syntax here is just like old syntax used in ways that are totally composable. The kind of like the little thorny thing is that we do somewhat already have like in non-pattern contexts and normal like expression contexts a way of doing this. And if you ever use the functional struct updating syntax, this is kind of similar, where in a struct, if you have like one instance of a struct and you want to make a different instance and you want to reuse, overwrite one struct with different structs fields, you can say, hey, like I can have struct A brace list some fields and then do comma and then dot dot the name of the other struct instance, and then it will any fields that you didn't name yourself, it will overwrite your new struct's fields with the fields from the old struct. And
Right. And I
so
think this is sort of how people try to emulate something like named function arguments, right?
yeah, so and it's often used in combination with the default trait to kind of get like default arguments too.
Yeah.
And so there's some question here. If you wanted to have dedicated syntax for this, it should probably like resemble that slightly, or is that like should it be replaced with this, and so on. So syntax questions remain difficult to discuss in public in the open. People always have an opinion, and finding a resolution that satisfies everyone is a difficult
I don't know.
job.
I'm pretty happy with the syntax. So
I think it works. Yeah.
so that clearly settles it.
I think I'm just happy that we can do it now, and that we haven't let syntax
Yeah, I think that's true.
block progress any longer. Where it's like it's nice to be able to do it, and it's nice that we didn't have to make new syntax. We're just reusing all the like syntax that already means what we want it to do.
Yeah, that's true.
So yeah, you learn to use add patterns. They're really cool.
Yeah, they are really handy. Speaking of patterns, the next thing that comes up here is something that I'm amazed hasn't existed already, which is the matches macro. So the matches macro is pretty cool. It just takes two arguments, where the first is an expression of any type, and then the second argument is a pattern similar to what you would write in any like match arm. And it just evaluates to true if the given expression matches that pattern, and to false otherwise. So it really just desugars to a match, or like match of the expression, where one arm is the pattern and maps to true, and the other arm is like underscore, like anything else that maps to false. And this is really handy for if you just want to turn like some complicated struct, you just want to check whether something is true of it or not. Previously, you had to write like either an iflet or a match and sort of spread it over 4 lines. Whereas now you can just use this new matches macro. And it comes in particularly handy in tests, where very often in a test, there are a bunch of fields you don't care about. Like you have some error type, for example, where you want to check whether the kind of an IO error is something that is one of these 3 IO error kinds. And previously, that was really annoying to check in a test. And now you can just write like assert matches your error and then a pattern like you would in a match, and it just works. I think the one thing I feel like is missing here is I want an assert matches macro that will debug print the expression if it didn't match. But I'm sure someone will like PR that. Mm-hmm.
You could write it yourself, perhaps.
I actually proposed it in the PR that added matches, and the response was, "That's a good idea. Want to submit a PR?" And then I did not. So it's wide open for someone to jump on. It should be pretty straightforward, and it would be a really cool addition.
Now, speaking of additions, this is the opposite, deprecation. And so a venerable part of the Rust standard library, error description, is deprecated. Do you want to talk more about what this is and what it does?
Yeah, so this is actually kind of interesting. So this is one of the this is something that was recognized pretty early on as being a mistake. So the error trait in Rust has a function description, and the description function has a signature of like reference to self, returns a reference to a stir. And initially this made sense, right? Like you want to describe this error and you want to give a string back, and it shouldn't need to be an owned string because why would it? Unfortunately, this has the downside that it basically has to be a static string or some string that's stored inside the error itself. But imagine that like the description for your error wants to refer to like a number that is stored inside the error, or some other error type, or some other type of a field inside the error. Then previously you didn't really have a way to include that in your description, because the description has to return a reference to a string. So you can't use, say, format inside of description because that returns a string, and you can't then return a reference into it because the string would be dropped when description returns. And so that is why description has been deprecated. And what is being deprecated in favor of is to just use the display trait. We already have a trait that is for writing a type out as a string, and it does not have this problem, right? If you implement display inside of that implementation, you can use like the write macro to write something that is formatted and uses debug and display. And you don't necessarily need to allocate a string, but you can still use the sort of string formatting that we want to be able to use in order to write out descriptions of basically any struct or other type. And so like description has existed since version 1 of Rust. And in Rust 127, this was sort of soft deprecated in that the description method on the error trait had a default implementation. So you no longer needed to add an implementation for it. And then in 142, it actually got like the official deprecated warning saying like, don't use or implement this, use display instead.
Yeah, I think it's interesting to review how the Rust error handling library situation has changed over the past few years, where I think the first back in the day there was error chain and then failure, and then all of these have kind of been like superseded by like changes to the standard library itself and have informed those changes, and so they're very useful. And these days I think my favorite is like this error. There's also by David Tolnay and also his anyhow crate, where kind of like they serve two different purposes, where one is like I want to consume and I don't really care, errors don't really care about what I do with them. And one is kind of, I want to produce errors. I want them to kind of have like a nice information and like take some more effort and time to set up kind of a like more fine grained, like, hey, I want like this throws this error, this throws this error. And they all work by the standard library's error trait these days. And you can derive error for any kind of, I think in this error, you can then derive the error trait for any, as long as your error enum has display on all of its fields. And I even saw a crate that builds on this, where you put dot comments on your error types, and there's a little kind of like formatting syntax for, hey, I want the error name in here, or like I want the field that the error variant contains here in this string, and then it takes dot comments, uses those to implement display, and then derives error, and then uses those display impls to do the right thing, essentially. And so it's getting pretty good.
I think it's really cool to see what's happening in the error space in Rust, and the fact that there's sort of still innovation going on there. One of the things that we saw was sort of the deprecation of description, but also the addition of the source method on error in addition to cause.
Mm-hmm.
And source allows you to actually downcast the thing you get back to a concrete error type. And this is part of what anyhow uses to be able to give you sort of recursive errors, even though there's only one error type. There are also some pretty cool experiments. Like I know Jane has been working on this thing called Eyre, EYRE. And that one is like taking a slightly different approach to anyhow. And it's also a really cool experiment. And I saw recently there was also an experiment to get Eyre to use this new track caller feature, where it will track every time you use the question mark operator, track the location of where that question mark happened, so that you actually get a full chain of where this error came from, rather than having to manually annotate things with like dot context, for example, if you're familiar with how this works in failure.
I want to back up. I haven't heard of this the Jane author before, but you're saying that someone named Jane is writing a library spelled EYRE. That's a hilarious pun. I'm not sure if you noticed that.
Yeah, this is Jane Lusby.
Okay.
So she does a lot of like really cool Rust sort of experimentation, and one of them is this Eyre library, EYRE.
Jane Eyre is a famous novel.
It is really funny.
So
yeah.
Okay, I wasn't sure.
No, it's really fun.
So awesome. Okay, and that I think there are also a few other like smaller library things in 1.42, which I don't think are very interesting. I'm not sure if you want to talk about any of them.
No, I think these are relatively minor ones this time around. I think the ability to use like proc macro token stream is nice, but it's not super important. One thing I do want to call out, you know me, I love diving into like the actual change logs for Rust and Cargo and Clippy and stuff. And one thing I observed is that Eric Huss has been doing a lot of work on updating the documentation for Cargo. And that's really cool. Like now the Cargo docs will actually explain things like features and workspaces in a slightly more structured and better way. And I think there are more changes coming down the line there as well.
Cool. The only other thing I see here in the Wii notes is downgrading 32-bit Apple targets from tier 1 to tier 3. And I think kind of that's just possibly an LLVM thing where it's like, hey, like we don't really have the resources to support this, and it's not clear who actually wants it. I'm not really an Apple user, so I can't really tell how new 32-bit or how recent was the last 32-bit Apple stuff.
I don't think you can get 32-bit Apple things
Yeah, I thought
anymore.
they made the switch back to 64-bit back in like the mid 2000s, but maybe I'm misremembering. Maybe that was the Intel switch.
Yeah.
I don't know.
No, I think you're entirely right.
I'm sure
you
got to know someone out there is, and I'm sure that they are, frustrated. But there's only so much what we can do. Platform support, and it's still there. It's still there. It's just not a tier 1 anymore. And there's tier 1 platforms or whatever the Rust compiler team tests for automatically and gates on, so you can't ship any kind of nightly that breaks any of these things.
That's true.
But it doesn't mean that other platforms don't work. I believe that there is we could link to the forge here in the release notes where showing, hey, like here is the Rust platform tier list, where here are what platforms are officially supported with, like, here's what Cargo supports, here's what standard library is compiled for, and here's where you're on your own.
Yeah. No, I think this seems like a very reasonable change where like this is like there are a bunch of platforms that like the Vim code base supports that someone might still be running Vim on those platforms, but it's as a hobby and not something that's worth spending a lot of developer resources and code complexity on probably. Mm-hmm. So I guess that leaves us to Rust 143. Which only came out like a week ago, right?
Yeah, we're actually not too far behind on this one.
Wow, look at us go.
As of time of recording.
Yeah, that's true. That's true. You're not wrong. 143 is interesting for a couple of reasons, and we'll touch on this a little bit later. But 143 has mostly minor changes, but I still think it's worth going through some of them because some of them point at bigger, interesting efforts in the Rust ecosystem. And the first of these is this notion of item fragments. So in Rust macros, for any given argument to the macro, you can specify the type for that argument. And the types here are more like types of syntax rather than Rust types. So you can say like this has to be an expression, or this has to be a block, or this has to be a type, or this has to be a path. And one of those types is item, which is something like a function is an item, a method is an item, a trait is an item. There's sort of like definitions, although people are going to yell at me if I actually say they're definitions. And one thing that was kind of weird about item fragments is that it used to be that if you wrote like a function, a top-level function, it wouldn't be considered an item that was valid in an implementation block for somewhat stupid reasons. And that's now been fixed. But I think this gets at a bigger point, which is there are a bunch of things in Rust, in both 142 and 143, where the changes are to add support for more syntactic things, like a top-level function that takes a reference to self. Like that code would never compile, but it is useful for the parsers to still allow that to appear there. There are a bunch of other similar ones if you look at the Rust changelog from 142 and 143. And the reason why these changes are useful is sort of twofold. The first is for macros. So Rust macros require that the input is syntactically valid. It does not require that the input is like semantically valid because the macro is going to rewrite it hopefully into something that is, but it does require that the input can be parsed by the Rust parser. And this is one of the major reasons why you want the parser to be pretty liberal in what it accepts, because it allows macro authors more flexibility in how they design the languages for the macros they write. The other reason to expand what the parser allows, what is syntactically valid, is that for things like error reporting and for code completion and such, you sort of want the compiler to keep going where it can, because if you fail at the parsing stage, you have relatively little information about what went wrong. All you know is that you expected one of these like tokens, but you don't necessarily know much about the context. All you have is the parser context. Whereas if you successfully parse it and then it's later in the process that you discover that like this function wasn't allowed to be there, then you can provide more semantically meaningful operations. Like you can say, we're in an impl block, so I was expecting fn, but I was not expecting like trait, because you can't stick a trait in an impl block, I think. And so it should be syntactically valid because it's only later at the sort of semantic stage that we know that we're in a trait block. And similarly for completion, it might be that even though your program is not currently syntactically valid, maybe because you're still typing, you still want the compiler to like parse and produce as much information as it can so that completion can help you wherever your cursor currently is based on the information that it can derive about the program. I think you mentioned, Ben, that you were a little worried about the parser being more liberal because of sort of stability guarantees. Can you say some more about this?
Well, I think I'm not saying worried. I think that's too strong. I think the idea is that just to like keep in mind that. So, for example, you might think, hey, like you have to use the example of I can't write a tuple function that has ampersand self as the first argument just because that makes no sense. And no matter what you do to the parser, that's never going to compile by itself. The difference is that, as you mentioned, macros. A macro will accept this, and you might ship a macro then that knows how to parse this and then transform it. And so when you make the syntax pass more lenient, that effectively kind of makes that's a promise that you can't take back, in other words. And so people could now begin shipping code on stable Rust that has a notion of what is valid syntax, and you can't ever break that code just because of backwards compatibility. And so this has kind of been going on for a while. I'm not trying to like say worried. I'm not implying that they're doing a haphazard job of it. It's kind of just one of those things where it's like, well, like, should this be part of the RFC process? I'm sure they don't want it to, because it's just they want to. A lot of what they're doing right here is for IDE support as well. I think Rust Analyzer has been a big influence on this current thing, wanting to share code from Rust Analyzer and extract code and kind of make the syntax classes simpler, the syntax library simpler as well. And so that's a big part of it. And it just kind of
I think it's a good point that this does become it becomes a part of the Rust specification in some sense.
Yeah.
That if you wrote if you wrote your own Rust compiler, it would also need to support this other syntax. Because otherwise there would be programs that would not work.
Mm-hmm. So rather than saying I'm worried about it, it's not that. It's more like I'm just saying that it is a thing to keep in mind, where you can't make in a language. It's not obvious is the thing. Is that a language where like you can ship syntactic or you can ship procedural macros, say like on stable, that have some notion of what it means to parse the language, that your parser can't get more restrictive over time, only less restrictive.
Yeah,
so
that's true. This next change is also one that's sort of relaxing something that previously wasn't possible. And here you wanted to, if I remember correctly, you wanted to draw a distinction between what Rust does for something like constant expressions versus what some other languages do. Can you say some more about that?
Yeah. So okay, I don't want to talk too much because I'm not like the expert here, but I know that, for example, I had to correct misconceptions in the release announcement for this in the comments, where it's like, oh, people are like, hey, like, so they look at the code example and they think, so maybe they know Go, for example, and in Go, constants are untyped, and so they use arbitrary precision arithmetic for whatever they're doing. And so if you like add two constants together in Go, they won't ever overflow, or if they're floating point, they won't, like, there'll be infinite precision. and that kind of thing, and they don't actually kind of like coalesce into a type or into kind of like whatever the types that you would expect until you use them in a program somewhere in a non-constant context. And so in Rust, this is not the case. And so you might like look at the example given in the blog post where it's like, hey, like, oh, like, does this mean that you're using like, arbitrary precision arithmetic for doing your thing? No, in Rust, the idea is that every numeric literal does have a type. And so if you type 0 to 0.0, that is going to be one of the floating point types. If you type 42, that's going to be one of the integer types. And so, as normal, as you expect in Rust, the Rust compiler will use the usual type inference algorithm to try and figure out what type that literal is. And the unique thing here is that if it can't, it will try and fall back for floats to F64 and for integers to I32. And that's just because otherwise it would be really inconvenient to write things like small tests or small examples where it's like, I want to just like, hey, print line 42. Oh, I can't because I have no idea what the type of 42 is. And so if you write just fn main print line 42, it works because Rust is just like, obviously it doesn't matter here what type of type is. And so we're going to just make it I32. And so this fallback only kind of kicks in when there's no semantic difference, because it's not going to try and do anything weird or magical with your types here. It's going to be if it can't figure out, if it performs the fallback and then something else happens, it doesn't like go back and try again with a different type. It just says, hey, like I couldn't figure it out. And so in this case, it's just of what this new change here. It's just a case of saying, hey, like making it a bit smarter about inferring the type. And so the fallback itself hasn't changed. It's just doing better type inference around what primitives might be.
Yeah.
So, yeah, that's it.
I mean, I think it's a good change. And it's interesting because it's sort of a small change, right? Like this is something where if you ran into this, the fix was pretty straightforward, but it's really just sort of fixing a wart in the type system, or it's not even a wart in the type system. It's just like a little paper cut sort of that someone would run into. It's easy to fix, but it should just work. Mm-hmm. And I think this is indicative of some of the fixes we've seen in latest releases that are starting to surface in the release notes.
Yeah.
And Steve Klabnik wrote a really interesting blog post recently where he had this thesis that Rust is changing less over time, like it's changing less now than it was. And he did a bunch of analysis of the release notes trying to figure out whether that was true. And the blog post is worth a read. And one of the conclusions he came to, I'm going to try to be careful not to misquote him here, but one of the conclusions was that over time, we're still making many changes, but the changes are more along the lines of like fixes or slight library changes as opposed to like syntax changes or introducing new concepts in Rust. And so they're sort of lower complexity changes. And so even I think his thesis was correct in that Rust, the language, is sort of changing less, but that doesn't mean that Rust, the standard library and the ecosystem, is changing less. And we see this a little bit in the
tool chain too, with cargo and all these things.
Yeah, exactly. And I think we see this in the changelog too, that some of the changes that are surfacing are smaller maybe than what we've had in the past. Like just remember when we had the async await release, right? That the changes in 143 are relatively minor, but that's not a bad thing. It just means that we're sort of getting into the groove of trying to fix rather than trying to add lots of new things, even though new things are still being added in the background. And I think this ties also into the Rust roadmap that was established for this year, which was this focus on, I forget what word they used, but sort of on stability, that rather than innovate, let's make this like the year of catching up to all of the rushing that we've done. Let's sort of take a breath, tidy up the technical debt in a sense that we've built up from adding all these features, and just sort of complete the language more. And then we can have another iteration where we add a bunch of cool new stuff later. And this, I think, is an indicator that roadmap is being followed.
Speaking of tiny changes, the tool chain, I think you want to talk a little bit about this cargo environment variable for tests.
Oh, yeah. So this change is kind of funny because it's something that I think for most of us, it just does not matter. It's very rare that in your tests, you need to know the location of a binary of that crate. But for some crates, it matters a lot, right? Think of something like bindgen or clap, where these are crates where the entire thing is, well, yeah, clap is a good example too, where the whole thing sort of revolves around running a binary, and you really want to test that that binary does the right thing, and you want tests for that that actually run the binary, as opposed to so that you actually test the glue code as well, right? And in order to do that, you need to be able to run the binary. But previously, figuring out where Rust placed a binary was a huge pain because, like, first of all, you need to figure out, okay, where is the target directory? That alone can be complicated because it's not always a subdirectory called target. For workspaces, it might be one level up, but the user might also have set something like the environment variable cargo target dir, which just moves the target directory to somewhere completely different on the system. And so you need to remember to check all of these cases. But even in that, like, you need to know where under target the binary actually ends up for this particular package's binary, even if someone has like renamed the directory or whatever. And this new change means that you just don't have to do that anymore. Cargo will just tell you this is where the binary is. And I think it's worth highlighting
that's
here.
useful.
Sorry, go ahead.
I was going to say, like, I was curious if you could use cargo run from within the test runner, if that would cause problems, because that would be my go-to for, like, where is the binary? Just use cargo run and it'll find it for me.
You can. There are actually crates that do this, and there's even a crate for invoking cargo from inside of tests. There are some reasons why you don't really want to do this, and this is because, for example, what do you do with the output? Right? In some sense, you don't want to run the entire cargo pipeline inside of your test. Instead, because you can't then like run tests in parallel, for example. It would be really nice if instead cargo just built your binary and then told you where it was, and then you just invoke that binary instead. And that's what this lets you do.
And this is not the first environment variable that cargo sets, right?
Yeah, that's true. In fact, cargo sets lots of environment variables. In most contexts, it sets things like the location of cargo, but it also sets a bunch of things about metadata for the current package. These are things like the version number or different parts of the version number, the name of the authors, the name of the package, like the link to the homepage, the description, that kind of stuff. And it also sets the output directory. So this is where am I compiling this crate into? This is something you'll often see if you're using bindgen, where bindgen needs to know, but bindgen generates a Rust file, right? That you then want to include in your other source code. And the way bindgen does this is bindgen writes it to the output directory. And then if you look at the include macro that the bindgen documentation tells you to write, that includes a file relative to that output directory. Because the output directory, in some sense, is the only place that any part of your build pipeline is allowed to write to. The source, for example, is generally read-only because your build process should not be modifying the source files itself. And if you have like cargo build scripts, they get a bunch more, right? So they get information about features that have been set, config options, targets, the host triple, all of these other things that you need in the like more meta context of I'm not just in the process of running this through cargo, but I'm actually like constructing a Rust program and invoking cargo.
So moving on to the library changes, I actually do have a thing to talk about that I was actually very involved with, as opposed to the previous one where I was just one comment in a long series of comments. In this case, I actually wrote this RFC, and it was for the change mentioned here where you can now use associated constants on floats and integers directly rather than having to import the module. And this is actually kind of a strange holdover from Rust 1.0. And so if you've used Rust, you've probably used traits, and you've probably seen there's associated types, associated functions, and there are also associated constants. You can have a type and say, hey, I want to be able to say this constant is this value. if I give it the type name. So I can say like, foo : uppercase bar equals 42, and that sort of thing. And the thing is, though, this feature, while it is natural to think that you would use this feature to say, like, if you wanted to say, hey, what is the upper bound of I32 or I64 or I128? Actually, associated constants were not in Rust 1.0. And the funny thing is, they were just barely not in Rust 1.0. They were, it was kind of like down to the wire. And they came, I think they stabilized 1.1, in fact. But because 1.0 still had to have these constants in them, the kind of stopgap solution at the time was, hey, okay, forget about it. We'll just, like, because we can shadow type names, and because, like, integer types are not, like, they aren't keywords or anything, they're just normal types, we'll just, instead of the library, we'll just have a module called I8 and I16 and I32 and I64 and U8 and so on and so on and so on, and we'll just put these constants in those modules, and for the most part, it'll work out. And so, whereas normally, like, if you were reaching for, like, hey, like, I want to get the max of this integer, you can't just say, like, I32 : max. You have to do, like, standard : I32 : max, or have use standard : I32 up in your program.
I see, because U32 and F32 there are modules as opposed to the primitive types.
Yes, modules. You have to actually, like, say, you have to actually bring them up. You can't actually use I32. You don't want to use I32 by itself, use standard I32 into your code, because then you're shadowing the actual type name. That could cause problems. Not any bad problems, just like annoyances for, oh man, actually, this is a bad idea. And so really, it was one of those paper cuts where even experienced programs would be like, oh, actually, yeah, this does suck. Why does it suck so bad? And I think I was hitting this last year, and I was like, man, why does this suck so bad? And just looking into the history of it, and it was kind of like, we needed to have these constants available somewhere, and associated constants just weren't stabilized until, regrettably, like 6 weeks after 1.0 came out. But also, it gets even worse, in fact, because if you looked at the functions, if you look, the documentation for I32, there is also a function called max value, which gives you the maximum value for I32 and I64 and I16 and all these things. And the reason for this is that type defs. And so if you are, like, say, like, writing a C library, or, like, doing a kind of, like, C code, and you want to figure out, hey, like, I have this, like, this type def thing. I have, like, this, like, this long or this short or this int, and I want to get the value of the max here, which is actually even more important in those contexts, because unlike in Rust, in C, you don't actually know what the underlying size might be. But if you have, say, like, an int, a C int, you can't just say use C _ int, because that module doesn't exist, because the hack that we used to actually get this to work relies on you giving the exact type name that you want. And so to get around this, they added in these functions. And so they were just like a max value. And so now you can write cint.max value to get the maximum value. So now we have two ways of doing the exact same thing. And so they're both kind of the wrong way, because there's no need for that to be a function. There's nothing dynamic at all about it. It's just a single value. And so this situation kind of languished, and, like, all the comments from back in the day that I compiled were like, yeah, we'll fix this someday. And then, like, 4 years later, finally, like, I come along and I'm like, yeah, let's actually get around to doing this. And it actually, the whole point of this is to show that, tying back into Steve's notion of, like, how often does Rust change? It actually takes a while to get these things through. So I published this RFC for approval, for comments, May 13th, 2019. And it is today, April 29th, 2020. And so it took about a year for this to go through the RFC process of, like, comment on this, implement it, and then stabilize it. And I also want to shout out to the person who eventually put in all of the effort for implementing this. And also at RustFest, finally pestered me to continue on, because what happened with this RFC was, it went on for a while, conversation got stalled, it was nobody's priority, as it hadn't been for the previous 4 years. And finally, I think Linus Fernstrand, I believe is his name, finally saw me at RustFest and was like, pestering me, like, let's do this. And he and I worked together to, like, really push the RFC through, ping the Lang team, or the libs team, that is, get them to kind of like sign off on it, and then he did all the effort of implementing it, which takes a while because you have to think about like compatibility, and like now that we have like 3 ways of doing the same thing as opposed to just 2, like how do you document this? How do you point users to the right thing? You want to redefine the other 2 in terms of this first one in order to reduce kind of like, maintenance burden or understanding, like if people are reading the code, like why is this like this? You don't want duplicated code in there. But also because you're introducing new things, you have to stage it appropriately, where you have to have things in nightly before you have them in stable, and so on. So it definitely it is a process, and so like anyone who says Rust changes too fast, for a lot of people Rust does not change fast enough, because for Linus he was like raring to go. And in many cases, people just could not move fast enough for him. And so anytime that like you see a change in Rust, just understand that these things go through a long process of discussion and approval and implementation and stabilization.
Do you think that the old versions are going to end up being deprecated?
That was one of the big questions of the RFC that we eventually kind of had to, the way that I worded it finally is that it is the opinion of the RFC author that these should be deprecated eventually, but we leave the timeline up to future decision.
Nice.
And so the idea is that I think the final decision was, yes, eventually they should be. It's not a huge deal to deprecate them. And so they might, I think ideally in my mind, they would become deprecated in the 2021 edition, if we have one. I'm not sure if that's the year that we're doing it. At some point there'll be an edition, but I'm not sure if it's next year or at some other point. And then maybe I don't know, possibly hard deprecated later on. We can do some things. I mean, it isn't a big deal. The whole point is kind of just for newcomers especially, you don't want to have 3 ways of doing the same very simple thing. It just kind of it's a bad look.
Yeah.
To use the vernacular.
I mean, I guess you can also do sort of the same thing they did with error description, right? Where you just deprecate it in this edition and point people at the other one, and then you only make it a hard error in the next edition, right? I don't think we need an addition to make it deprecated. Probably.
Well, I think even in this case, error description is not actually becoming a hard error, I don't believe. It's just deprecated.
No, it's just deprecated for now, but I think the intention presumably is for the next edition to make it.
That's actually, maybe? I think that's still up in the air. I think it's actually interesting to talk about the whole like edition format and the things that we can do. Obviously, like the point of editions is that if you have Rust 2015 code, a crate that's 115, a crate 2018, crate 2020, any crate can use any other crate freely without having to make any changes. And that's the cool thing. And so like it is honestly totally imaginable that you could say, hey, like if I'm a 2021 edition crate, just like don't let anyone using this edition use any like thing marked as like hard error 2021 edition and so on, and then as an actual like step to upgrading your code, you would then like if you opt into the edition, you would then take that out or like upgrade to the newer way.
Yeah, it would almost be like a lint that becomes deny.
But I don't think there's ever actually any precedent for doing this is the thing. Like I think there's no precedence for doing an API change this way. Maybe for like some semantic changes. I think so. For example, another RFC that I wrote for the 2018 edition, which was don't let numeric literals overflow their type, which became I believe from a warning to a hard error in the edition. So it is possible, but I don't think it's been used for API changes.
Yeah, I mean, it's a good question, right? This ties back to what are additions and what are we allowed to do? Certainly one thing I guess that would be necessary is that it would still, if you compile against a dependency that uses an old addition, it must still be allowed to use description. Mm-hmm. And so the deprecation, yes. It would really be like the deprecation becomes a warning, becomes an error rather than a warning in the new addition. But that doesn't mean the description itself goes away.
And no, it never goes away. And again, because it never goes away, you can't actually ever reuse that. Like, so that word is like forever used for that purpose. And the only thing you can do is either say, hey, in the new edition, you can't use this. You can't ever make it do something different.
Yeah.
Say, because you don't ever want to have 2 symbols with different functions in the same program.
Yeah. And I mean, we saw this with error cause and error source, right? Where
yes,
arguably cause should just be source. But you can't do that. That wouldn't be that's not a pipeline that we can do without like a severe breaking change.
Mm-hmm. Wouldn't be compatible. So
There are actually a few other things that I want to mention here. One of them is in the library changes, which is there's a new primitive module in Rust. And the primitive module is really just a module that re-exports all of the Rust primitive types, like I32 and I64 and F32 and all of these things. And you might wonder, well, why? Why re-export these? And this ties back to something we've talked about a couple of times on this podcast, which is if you're writing a macro, like you can't rely on the user's environment. If you do something like just use the I32 type, who knows whether that is the I32 type that you expected to be using? The user might have some like crate level rewrite or something that just means that that is just a completely different type. And the new primitive module is a way for you to say, I want to use I32 from the standard library, no matter whether there are other I32s that exist in this crate. And you really, it's basically.
I do like this.
Yeah, I mean, it seems like a sort of weird change, but if you think about it for a second, it actually makes a lot of sense. It's a way for macros to opt out of shadowing for Rust's primitive types.
Yeah, well, also, I'll even use macros. I'll even write macros, really. But the reason I like it is kind of because, like, in Rust, you have a prelude, which is kind of things that become in scope automatically. And so, like, option, none, sum, result, these things, you don't need to actually import them to use them. And so it may be, it's easy to overlook the fact that, like, all the primitive types aren't actually in the prelude. They're kind of just, like, magically there floating around. And so this kind of makes the primitives a bit less magical. Like, hey, you can say, hey, like, these do live here, more or less. I think the way that the crate's implemented is that it actually might, like, instead of actually making the compiler say, hey, these live here, and adding new items for every single one, it kind of just uses, like, trickery to say, hey, like, we're going to just export these types as they are.
Yeah, I think that's right.
But it's, as far as the user's concerned, it's the same thing. So
yeah, it's funny you mentioned the prelude, because that's another thing they're discussing for the next edition is what things do we add to the prelude? And there are arguably a couple of things that people want to add, things like maybe future, maybe try from and try into. I've seen questions about like into iterator and from iterator. I think into iterator maybe already is in the prelude, but from iterator it's not. And so there's an issue that you can look up, which is like things that are being considered for the prelude for the next edition. And it's a pretty interesting read.
Yeah, we'll find that link from the show notes. And I think now is the time, if you actually care about these things, to get involved, because the idea is to probably by like later on this year to have an idea of what's going to change in the next edition, and then spend 2029 actually doing it.
Yeah.
As opposed to the previous edition, which was kind of like just at the last minute, oh, what are we gonna do? What are we gonna do? What are we gonna do? And like freaking folks out. We have some talks from our podcast has hosted some talks from people who were involved with that, saying, hey, that just definitely burned everyone out and did not go over, like, even though it went over well, like, for users, it definitely had its toll on the developers.
Yeah.
So we want to avoid that this time. If you want to get involved with 2021 edition changes, you want to speak up now and get involved. So.
Or forever hold your peace.
Or I guess until the next edition comes around. So I wouldn't say forever. For 3 years, hold your peace.
There are a couple of other like smaller things I want to bring up sort of on the tail end here. One is that string now implements as mute stir. This was a really funny change to me because like strings should obviously work as mutable reference to strings, but the fact that it wasn't added until 143 shows just how little people use mutable reference to strings. For good reason, right? Like, a mutable reference to a string is a really weird thing because it's UTF-8 encoded. Like, it's very rare that you can mutate anything in place anyway. And so I'm glad this impl was added. It's sort of there for completeness. But it was just funny to observe that no one has needed it until now.
And I think this kind of like goes to show too. I think in Steve's blog post kind of like talks about, hey, most of what is added is library types, standard library types, or standard library functions and types and that kind of stuff, traits. But at the same time, Rust has a strange reputation as having a small standard library. And so there's a kind of like discussion to be had about like some standard libraries are broad, some are very deep, some are broad and deep and or could be broad or shallow. And I think Rust has a very kind of like narrow but deep standard library is the thing, where it's like there aren't really that many out there modules that give you like, there's no like web server, there's no regex. say. But like the things it does give you, it gives you an extreme amount of like control over, where it's like all the combinators, all the like little reference types that you can do, all the transformations, the into, the from, impls. It's very extensive, and it's an interesting contrast to say with like Python, which is both a very broad and very deep
Yeah.
sort of thing, language or standard library.
I think as with every version, I also want to touch briefly on like the ecosystem beyond the Rust language itself. The first of these is in Cargo. Cargo has some neat new features in this version that that might not be something people notice straight away. The first of these is that in your system-wide cargo configuration, you can now use the cargo profile flag that was introduced, I think, in 141, I want to say. So in 141, just to recap, you got the ability to say in your cargo toml that, like, when you compile this crate, always compile this dependency in release mode. This is handy if like you depend on, say, a compression library or something where even if you're running tests, you need that dependency in release mode because otherwise your tests are going to be too slow. And what has landed now in 143 is that you can now set those kind of profile overrides in your global cargo configuration. This is really neat, right? This means that I can say something like always compile like a hash or fx hash in release mode, no matter what crate I'm compiling on my system, because I know that the performance of it will just always matter. And I know you, Ben, were surprised that there was such a thing as a system-wide cargo config in the first place. And I think this is worth pointing out too. So in your configuration directory for cargo, which from memory is like home / dot cargo / config.toml, there are a bunch of different configuration options you can set. So one of them is that you can add aliases. So this is where like cargo T is defined to test, but you could add other aliases too to define additional cargo aliases. You can do things like set what should the default metadata for crates be when I run cargo new. What like network settings should cargo use when it fetches stuff? And there are a bunch of other things you can stick in there. And then, of course, one big new one now is you can set these global profile overrides. And that's really cool. The other new feature that's in Cargo, although still, I think, in Cargo Nightly, is that Cargo is getting a new feature resolver. So the current feature resolver, this is sort of, if you're in a crate and you say, I want this feature, what happens? Or if you defined a dependency with some feature and then some transitive dependency of you also depends on the same crate with some different set of features, how does Cargo resolve those? And Cargo is getting a new version of that component that you have to opt into. And this fixes it fixes a couple of different issues. One of the big ones is that currently the resolver, imagine that you depend on, say, Tokyo, right? So the Tokyo crate has a bunch of different features in it, feature flags that enable things like, do you want the multi-threaded runtime? Do you want support for I/O and whatever? If you write a crate that only needs, say, the traits that Tokyo defines, but does not need anything else, it doesn't need the runtime. But then in your tests, in your dev dependencies, you do need the runtime because you need to actually run the tests. So in your dependencies, you list Tokyo with like the traits feature or whatever. But in dev dependencies, you list Tokyo with like all features turned on. Then the current resolver is actually going to compile Tokyo only once, regardless of whether you compile it for testing or as a dependency, and it will always include the union of all the features. With this new resolver, it will only compile the features that are needed for the particular thing that you're compiling. And this is really handy if you have a dependency on such a crate. If someone has a dependency on my crate, I don't want them to have to compile like the multi-threaded Tokyo runtime if they don't need it, just because I had it in my dev dependencies. This is, of course, a backwards incompatible change. This is why you have to opt into it, because it could be that I forgot to list a feature in my dependencies, but it magically worked because it was listed in my dev dependencies. Whereas now the cargo does the right thing, I'm now lacking that feature. My code will no longer compile or run correctly.
And I'm wondering if that might be the kind of thing that might, even though it's opt-in, it might become automatically added to your cargo.toml if you have in the new edition. And so just like how if you have a new edition and you type, cargo new, you automatically are using that new edition in your cargo toml. Maybe at some point that could be automatic.
That would be my guess. This new resolver fixes a bunch of other things too that I think makes it pretty obvious you would want it to be the default. For example, it means that now features in workspaces are much less of a pain. Previously, if you were in like the root of a workspace and you wanted to compile some particular subcrate with a feature enabled for that subcrate, there just like wasn't a way to do that. And with a new resolver, you can actually express this. And it's just like, it was a problem, and that problem now goes away with the new resolver. But sadly, the new resolver is not backwards compatible completely. But I think it will actually lead to things like shorter compile times, because you will no longer compile quite as many flags. And generally, not including a flag removes dependencies and thus reduces compile time. There's one last thing in the ecosystem that I think is worth highlighting, because it tends to sort of be forgotten, which is Clippy has gotten really good. And if you're not aware of this, like try going to the release notes of the last few Rust releases, click Clippy and like the more detailed changes towards the bottom and look at the changelog. And you'll see that every single release adds like a heap of new lints. It changes a bunch of the existing lints to get rid of false positives, for example. And some of these are really cool. Some of them actually catch things like correctness issues. So for example, if you use, say, the atomic types in Rust, then you'll be familiar with the fact that you have to pass in an atomic ordering for every operation. And only certain orderings are valid for certain operations. Like, for example, you're not allowed to do a load with, I forget, you're not allowed to do a load with release or a store with acquire. And previously, that would just crash at runtime. The load operation would say, you told me to use this ordering, and that's not valid, because ordering is just an enum, and it can't type check the particular variant. Whereas Clippy will actually catch this for you. Will say, you're trying to do a load with release ordering, and this will crash at runtime. Your program is wrong, and actually give you an error for that case. So I really highly recommend, if you're not doing it already, like update Clippy and run Clippy on your programs, because it will catch correctness things in addition to just unidiomatic code, which is sort of where Clippy started.
And to get Clippy, it doesn't come by default with Rustup. I think you need to do Rustup add component Clippy, right?
I forget, this might actually have changed with the Rustup profile stuff that landed a while back. But yeah, if you don't have Clippy, then just do, I think it's Rustup component add Clippy.
That's it.
And then you get it. And you have to add it for each different tool chains. You want to add it for like stable and beta and nightly if you are using all those different tool chains. And it's really neat, right? So Clippy tries to be somewhat conservative by default, and there's been a push around that recently for getting rid of lints that were maybe overly annoying and not that helpful. Where Clippy actually differentiates between lints that are correctness bugs, lints that are idiomatic, which are on for warnings by default. And then it also has this large category of lints that are pedantic, which are turned off by default, like they're allowed by default, but you can opt into them if you wish. And this can also be a good way just to, if you want to learn more idiomatic Rust, like turn on pedantic Clippy and just see what kind of things it suggests. And not all of them might be great. Some of them might give false positives, but they might give you a sense for ways in which you could change your code to make it more rusty. I think that might be all I have for 143 and consequently also for 142.
Yeah.
Do you have anything else you want to pitch?
No, I'm good. So I think we're about ready to wrap this up.
Nice. Are there other Rustfest interviews coming? I'm forgetting whether we have more.
I have one currently in the works. It may or may not be released. It'll be released before this one does. But then we have one last one, and then who knows? I mean, Rustfest this year, because of the incident, has gone. I think they're trying for a remote conference around December. So it will probably be not the kind of circumstance that will require any kind of interview, but I will be trying to get interviews as I can for people who are doing cool things about the edition this year, I think. And so
Yeah, that'd be great. That sounds like a
wanted
great
to perhaps
idea.
interview Nico Matsakis, maybe Felix Klock. So yeah, keep an eye out for those.
Yeah, I think that would be really cool. And a reminder, of course, to everyone listening that you can
You
also
can.
contribute to this podcast. The goal here is for this to be a community thing. If you have an idea, even just for a single episode of someone you want to talk to or some project you want to talk about, then like reach out and we will happily help you make it happen. We have people who know sound. We have people who can help you getting it published. And that would be awesome. That's how we get more content out there. And especially given the incident, it's really good to like produce more of this content that people can listen to. If you saw the recent Rust survey results that came out, people are really looking for sort of more in-depth Rust content that goes beyond just the beginner material. And I think things like interviews with people who are experienced with Rust could be a really good source of that kind of information.
All right, well, that's been good hearing from you again, John. Let's do it again before too long.
Absolutely, Ben. Likewise. I'll see you soon.